Hey guys, welcome back. I'm gonna go through how to use the sine rule. There's also a proof of how to derive the sine rule, which I'm not gonna cover in this video. Maybe I'll do that in a later video. But for this one, I'm just gonna go over how to use it, okay? So I just wanna say, before this point, everything we've done in trigonometry was based off of right angle triangles, right? So we had like right angle triangles, and then we use this idea of like so, toa, and then we got introduced to sine, cos, and tan, right? This was all based off of right angle triangles, okay? So now the problem becomes, okay, when you have a triangle that is not right angled, we're gonna need some new ways to deal with these questions, okay? So the actual way to derive the sine rule is actually just by drawing a straight line down and then working with two right angle triangles, okay? Like I said, maybe I'll go through that proof in a later video, okay? So in this one, I'm just gonna go through what the sine rule is and how to use it. So we've got this non-right angle triangle, and let's say that I'm gonna call this capital A for this angle, and I'm going to say that's capital B for that angle. Okay, for angles we usually typically write it in capital letters, and opposite we're just going to write the side lengths. Okay, so the sine rule is this: A over sine A equals to B over sine B. Okay, sometimes in textbooks you'll see that they might add another, like they'll call this C, and then that side C, and they'll add that that's the case as well. Okay, so that's definitely true, but for the purpose of this, a lot of the times you're usually just working with two sets of sides and angles. Okay, so as long as you know that two of them are equal, of course the third one you can surmise is equal as well. Okay, so what I'm going to do is basically use this formula, okay, to answer a couple of questions to show you how it works. Okay, so I've drawn a couple of triangles down here. So let's just say for this guy, we're going to say the sine rule is x over sine 70. So the side over the angle that's opposite that side. And then we have 5 over sine 20. Okay, so hopefully you can see that. So basically I just said, okay, this is like A, this is like capital A, this is like B, and that's like capital B. Okay, so once you have this, we can multiply sine 70 to the other side, right? So let's say x equals to sine 70 multiplied by this. Okay, now the question actually says to give it in 4 significant figures. So if we calculate this number, we will get x equals to 13.75, and let's just write 4 significant figures. Okay, and that's the answer for that one. So hopefully that was nice and straightforward. The last question I'm going to go through before we finish up this video is this one down here. So in this one, instead of finding an unknown length, instead of finding x, we actually have a theta that we're going to find, so like an unknown angle. Okay, but the first thing to do is just to write the formula down, right? So maybe I'll just write these markers just to help you guys, but we'll say that's A, the opposite one is capital A, B, and capital B. So we can say 5 over sine theta is equal to 7 over sine 42. Okay, now seeing as theta is the one that I want to find, we're going to just flip everything over, sine theta over 5 is equal to sine 42 over 7. Okay, now with that being said, if you were to ever do a question like this in the future, and you know that the angle is the one that you're looking for, maybe after a lot of practice, you can just skip this line and just jump straight to this, right? Mainly with the idea of putting the polynomial that we want to find on the numerator. Okay, because if it's on the numerator, then we can just multiply the denominator over and we can get the answer straight away, right? So last thing we can do is sine theta is 5 times sine 42 on 7. Okay, and then eventually we're going to sine inverse this value, right? So theta is equal to sine inverse of all of this. Okay, all of that. And if you put in your calculator, we get 28 degrees and 33 minutes. Okay, to the nearest min. Okay, so that's basically the size of it, how you do sine rule. Okay, and in the next video, I'm going to go through how to do cosine rule. Alrighty, I'll catch you guys in the next one.